Good morning. My name is Richard Giardini. I'm with Sigmund Environmental Services, Inc. We are the Prominent Fluid Controls, Inc. chemical metering distributor in southern New England. With me today is Ross Crawford from LRM, and together we're presenting this training program on the D1C chlorine analyzer. And we will be here for probably the next hour and a half. Reviewing the items of safety, applications, wiring, the control and operation, calibration, the different menu screens, setting some of the variables, maintenance and troubleshooting. There's a 15-minute break, and after that break, we're going to go outside. And we're going to look at the 3 installations that are currently out there. And hopefully, if we had a successful session here in this classroom, what you see out there will be very recognizable. The D1C, which is the model of this chlorine analyzer by Prominent, is designed to give you a continuous read of chlorine, whether it be free or total. In this case, it's total. As opposed to having to take grab samples or have a different type of sampling measurement system where it may be periodic, once every 15 minutes. This is continuous. And it's continuous because it's an amperimetric sensor, and it essentially functions by reading a potential between 2 electrodes. Now we have a sensor which is right here. This is a sensor in a holder, and we'll get into this a little bit later as far as what it really looks like and how it operates, but that's basically it. When chlorine is in water, an electrical current is generated based upon the concentration of that chlorine. This sensor is designed to pick that up. It converts that signal to a 4 to 20, which you could use to send to this instrument to display the chlorine concentration, to control your pump, to send it to a recorder, to send the signal to a SCADA system, which I think is the situation here, where that SCADA system then controls your operation. Safety concerns. The D1C operates off 115 volt electricity. So whenever you have to remove the cover, as we have in this particular case to show you what this thing looks like, you have to unplug it. And you say, okay, well, when would that ever happen? Well, practically never, because once the electrical connections are made on the inside, it's done. It's sealed, weather-tight seal. If there's an electrical lightning strike, there is a fuse in here, and if that fuse blows, then of course that would be a reason for removing the cover and replacing the fuse. I've yet to have one go. So I would say more than likely you won't be involved in removing the cover.
Well, in your case, they're not plugged in, they're hardwired into a panel in the pump room down there. Okay, you guys see at the effluent tank, okay? There's a panel in that effluent tank with fuses in it, with 3 fuses for each of the 3 instruments. Okay? That's what you guys have yours on. There's no plug in each one. There is a fuse here. There's a fuse here. But there's also a main fuse and an electrical panel in the room down there, in the pump room.
It's actually a breaker, right?
I thought there may be both.
Okay.
There may be both, because I had said break. I think it's a fuse. There's a breaker also, I'm sure. I think there's also a fuse for each one.
Okay.
Please, if you have any questions along the way, just pop them out. The sensor works on the principle of an electrolyte, which is placed inside a membrane cap, and it allows the transmittal of that current from the outside to the inside. The electrolyte is a very viscous, thick material. If you thought honey was thick, this has got it beat by a mile, all right? But it's extremely safe. Don't worry about it. Get it on your hands, just wash it off with warm water. It's really non-toxic in that sense. Typical applications for the use of this instrument. We would monitor free and total residual chlorine. You could also use it to monitor pH, temperature, chloride, fluoride, a number of variables. These are items which you're really not going to get too involved with because your system is being controlled outside of this box. But in some other instances, it has the ability to provide a feed-forward control of your chemical metering pump by just taking a wire out of this off the right terminal and bringing it into your chemical metering pump. Indirect control through the SCADA system and full proportional integral and derivative, or PID control, again through this box. What this box is doing in your application is just displaying your residual value of chlorine and sending that value out to your main panel, and there it's being processed. In this manual is a wiring guide, and basically two wires that go to two terminals on the end of the sensor, and then it connects into two terminals on this box. And this little wiring guide, again, which you have in there, tells you exactly which terminals things are to reside on. Real simple. If you really wanted to get into this thing, well, there's a full wiring diagram if you wanted that too. And again, this instrument has the ability of alarming on high or low and taking other inputs or actually sending out control signals. But again, all you're using this for is monitoring with the 4 to 20 going to your SCADA system. I'd like to pass this around because this is the instrument, and it's important that you look at it, see what it's made up of and how this thing works. You have, as I said, 3 of these already installed. The 4th one, this is the 4th one, which will be going out. There are basically 4 programming keys on this instrument. This red one is a start and stop. It actually will pause this instrument from working. It's not an unplugging. It doesn't stop the electrical current from coming in. It's just a pause, a start and a stop. This upper key here, the change key, allows you to enter the programming menu. And we have a number of those menus which we will see. The down and up arrows are exactly what we would think them to be, changing your value, either up or down. This is used as an enter key to record what you have changed. If you do not press the enter key, your changes will not be registered in the instrument and you won't see any change. This key essentially moves you back up a level into your programming mode, and if you hit it, I believe, twice, it takes you right back out of the programming mode where you now are displaying your chemical, your residual chlorine value. So you basically just have 4 keys that you have to deal with.
These keys don't make a lot of sense to us because this instrument was kind of developed in Germany and Europe, and these are European symbols that they used, okay? And so that's why they don't make a whole lot of sense to us. So, I mean, you may want to, you're only basically going to use your change key, your up and down arrows, and your enter key, for most of the stuff that you're doing when you're making corrections to chlorine residuals, okay? And after you do it 2 or 3 times, it's just going to make sense to you as far as what key you're going to, okay? Go ahead, Richard.
Here's our sensor, and here it is right here, and you can see that it's made up of a number of parts. But I'm just going to focus on 2 parts. This is basically the main sensor element. Here's where your 2 wires get connected to. and here are your electrodes down here. This is an instrument which basically, under normal circumstances, you buy once and it just works for you, okay? I mean, I've yet to have to be involved in a project where that is replaced unless it's damaged. But this is basically a permanent fixture. However, the membrane cap, which is on the bottom, which is filled with the electrolyte, has a membrane on the bottom, and I'll pass this around. I ask you not to touch the membrane because this is a live or good piece of equipment here. Needs to be changed periodically, dependent upon the water quality that it's sensing. The dirtier the wastewater, the more frequent you have to change it. What's frequent? For some reason, Brattleboro, Vermont, the wastewater treatment plant, must be an extremely bad effluent because they have to change these once a quarter. Generally, I find 8 months to a year is the more common schedule of replacing the membrane. Now, when we service the membrane, we would withdraw this sensor holder out from the liquid that's being sensed. We would unscrew the bottom, that's around here, there it is, essentially, you would unscrew the bottom to expose the membrane, unscrew the membrane, discard the old one. This is the electrolyte. This is a cone cap. We would screw this on the top of the electrolyte. Now, what affects the reading of this instrument is how accurate and careful we have placed the electrolyte inside of the membrane cap. If we have permitted a significant amount of air bubbles, that's going to impede the transference of that electrical current to the electrodes. The procedure that Prominent recommends, and I've done it, and it really works, is that you extend, first of all, this is on the top, I squeeze the bottle to get all the air out until I start seeing electrolyte coming out of the top. I turn it over and I place it all the way into the bottom of that membrane cap, squeezing the bottle, and as it fills, I'm lifting this out. Very rarely do you get any air bubbles that way, okay? And it works great, yes.
Question, is this a type of preamp in here, or is it just a connection to the unit?
No, it's a connection to the unit. That's where it gets its source from.
There's no amplification, no type of circuitry in here besides just a connection to the...
Well, from the circuitry that I'm aware of that's in there is that these probes or sensors are manufactured based upon certain range limits. 0 to 0.5, 0 to 2, 0 to 5, 0 to 10. That programming is integral to that sensor, okay? And that's the kind of wiring that is in there, the kind of memory that thing has. But it requires the connection back to the D1C to be activated.
My question is that if there's a problem down the road, would we be looking just at the sensor, or the unit, or could possibly be this?
You can't fix the part that's inside of that.
This
You
here
can't do
is-
anything with that.
This
If you have
is
a problem.
There's no maintenance you can do on this. If there's a problem during the warranty period, you send it back to the factory, or we have to get another one for you.
So what I'm saying is, would there be 3 items that possibly in effect as far as the sensor at the end, this unit here, and the receiver?
The electronics
Yeah,
transfer.
that sums it up. We have three basic quantities.
We look at the
Okay.
sensor, and there's a problem,
Yeah.
and it didn't correct it, will we look at this unit next and then go to the
Yes.
Yes.
This does behave, I'm sorry,
No, go ahead.
This does behave like a 2-wire transmitter. You can
Okay.
put a simulator on it and simulate 420 milliamps through this unit.
Okay.
And you should be able to, simulate a 2-wire transmitter. You should be able to simulate, 12 milliamps and have half of your range.
More than likely, the service to this unit is going to be in the membrane.
I understand understand. My question was, if there was a problem, we couldn't resolve it through the membrane, could it possibly be the
It
service?
could, absolutely, and that would be the next thing we would look at, yes.
Thank you.
The service that I see you guys doing is withdrawing the sample tube, the sensor tube, out of the liquid, removing the cap end to expose the membrane, removing and disposing the old membrane, and installing the new membrane, okay? From what I've seen of the wastewater